Federated queries join data across all systems. I'm going to run some queries that join across each one of these systems on the left, and then I'm going to show you the techniques to do it right. This first query is 19 different tables from 19 different systems, and there they are. Here's the SQL. Notice it's all uppercase. That's actually Snowflake SQL because Snowflake is the hub where we will process the join. Down here, it shows me all the tables and all of the data and the values, so I can make a good decision about where I want to process this. I'll explain that as we move forward. Now, when I hit execute, because Snowflake is the hub, the Nexus will convert each one of these foreign tables from other systems into Snowflake tables. It'll build load utilities depending on which system and move it, and there is the report that was run on Snowflake. Now, the tables that have moved over to Snowflake will stay there until I get out of the super join builder. So I can make changes to the SQL as I'm doing now, and I will run this again. I've got a different order by in there, and it executes because those tables exist. If I were to look at the Snowflake tree here and go to the database where we process this, you're going to see that there are these foreign tables out there with these numbers on them. That's how we do it. Those are temporary tables that have been moved over. They will stay here so I can do as much as I want to do while these are here, but then they will be dropped when I get out of the super join builder or I change the hub. Now, this is important. Everything moved through my PC, but I have a Nexus server out on AWS. I can put it anywhere. And I've scheduled this job to run out on the Nexus server. Now everything is moving from their original database system through the Nexus server and onto Snowflake, and there's the report again. So when you have big data, you need data movement from the source through a server and onto the target, and that's what we've done here. I just changed the SQL hub to SQL Server, and it changed the SQL to TSQL. I'm going to change the hub now to MySQL. This is now SQL written for MySQL. When I hit execute, all of the tables will move to the MySQL system. There's the load utilities there. And now that they've moved very quickly, there is the same report, same federated query. Now watch this. This is brilliant. If the data is not humongous, you can change the hub to my PC. Nexus is querying every table individually, bringing it back to the PC, and it put the report together. I can do my PC hub, but run it from the Nexus server. Now, every table's moving to the Nexus server, where it will be joined in the background by the CPU of the Nexus server. The CPU in memory is what it takes to join that data, and there's the report again. Now, let's do some humongous data. We'll do a 1,000,000 row table. It could be 500 million rows. So I will show you a wide variety of techniques here. Now, I just got in the super join builder and dragged in the claims million table. There's 1,000,000 rows in this, fairly big. Now, I'm going to join it to a yellow brick table. So I open my yellow brick tree. This is just one technique to bring tables into the super join builder. I'm going to now just drop and drag the subscribers table into the claims million. I touch it, and now it says, how do those two join? I go subscriber number, blue button, member number, blue button, and then I say finish. And now it knows it joins on subscriber equals subscriber, member. Now let's do a Vertica table and bring it in, but I'm going to do it a different way. I'm just going to do a search for subscriber number, and the Nexus searches every system, and there it is on Snowflake, there it is on Yellow Brick, and here it is on Vertica. It shows me that I've got an addresses table with subscriber number. I drag it in, touch the table that I want to join it to, and it joins on subscriber equals subscriber. I've got my 3 tables of the federated query. Now, the first technique, the reason you want to have control of the hub, once I pick the columns I want on the report, the SQL is built. Teradata was the first table in, so it's the default hub up there to the right. So that is where we're going to process this. And since there's 1,000,000 rows in that Teradata table, everything that's smaller is going to move to the Teradata system. So that's a brilliant idea behind having a hub where you can choose where you want to process. There's 1,000,000 rows that came back. I'm just going to say, no, I don't want them all. We got our 7,000 here, but 1,000,000 were joined. But see, watch what happens now. I'm going to change the hub to yellow bricks. So in a sense, we're going to move that 1,000,000 row table over, but we have high speed utilities. This YB load is very fast. Postgres imports extremely fast. So when you have high speed utilities and you execute this on a Nexus server, that's where we've scheduled it to run, this data will move extremely fast. So it's the high-speed utilities. There's the report. Hey, we'll just take the first 7,000 rows, but that joined 1,000,000 rows very quickly. Here's another very important technique. We have 1,000,000 rows here. We're going to filter. We don't want to see all 1,000,000 move. If you filter at the table level, where the year is 2017 and the month is February, it's only going to move the columns and the rows it needs to. And that's going to be a very intelligent way to take humongous tables and get the data out of them you want. I did not move all 1,000,000 rows. I only moved about 20,000 rows here based on that where clause at the table level. So it's before the data moves. And there's my report. Now watch very carefully here. I got into the super join builder by right-clicking on the table. I'm going to do a create cube with columns. This is going to join everything possible on my Teradata system, and I'm going to grab that SQL. Now that I have this, I'll just do a Control A and then a copy, and I'll have this Teradata SQL. It's another great technique for integrating data. Now I'm going to go to the Nexus server, which is a server, as I said, on AWS. I'm going to go to the Nexus SQL and say, I want to run actually SQL on Teradata system. Here it is. I just pasted it in. But instead of returning the results set, I want you to load it to a table. Yes, I want you to run this query on Teradata. Maybe brings back 500 million rows. And then I want you to not return the result set. I want you to save it to a Postgres system. And I want you to call it AAA_Teradata table. And now let's schedule it to run. It's going to use Postgres import, another fast utility. And we can schedule it once daily, weekly, monthly. Let's do it immediately. I can give it a name so I can call this up later. We'll just call it Teradata to Postgres. This job is scheduled. It's running right now, and it has run. That's created that table out there. Let's go check it out. There's our Postgres. There it is. I'll just do a quick select. That data exists out there on Postgres, but ran from Teradata. Fantastic. And you know what? You can change the view to, let's go with dark high contrast. Now we're just showing off. It's silly. It's really important that you be able to reunite your data